So in this chapter, we've looked at chemical formulas and converting different units, but the one thing we haven't really talked about up to this point is chemical equations themselves and kind of what is represented in a chemical equation. And there's a few things that you need to recognize. In a chemical equation, you'll have coefficients, which are kind of these big numbers written in front that tells you have two H2s or two H2Os. You have your element symbols, hydrogen and oxygen, both on the left side and the right side of the equation. And you have your subscripts, which are the little numbers telling you how many of something that you have within a formula. The other important idea is understanding the differences between what's on the left side of the arrow and the right side of the arrow. The things on the left side of the arrow are your reactants, so hydrogen and oxygen gas are your reactants, and you have H2O, which is your product, which is what you're going to end up with at the end of the reaction. A couple other symbols that you'll see in reactions that you need to be aware of is you'll see S, L, G, and AQ, sometimes written in the equation. So in this reaction, we have G next to H2 and O2. That just means that those things are gases. H2O is an L, which means that it's a liquid. If you see S, of course, S will be solid. And the one that's probably the most foreign to you would be the idea of something being AQ or aqueous, which means that it's going to be dissolved in water. So what we really want to look at here are different types of reactions. And there's four main types of reactions that you need to be able to recognize and identify. First one is a synthesis reaction. And as long as you understand what the word synthesis means, synthesis means to make something or to join things together. So that's exactly what happens in a synthesis reaction. You take two substances and they combine together to form a single substance. So an example of a synthesis reaction would be something like this. If you take two sodium atoms and a chlorine atom and they join together to form salts. We said in synthesis things are joining together, and that's exactly what's happening here. Na and Cl are combining together to form salt. Another example would be synthesis of water. Synthesis of water, you're taking hydrogen gas and oxygen gas, and they're joining together to form two water molecules. With all of these reaction types, the biggest thing is going to be knowing what to look for. What to look for in a synthesis reaction is that your product is always going to be a compound, because you're always going to be joining things together. So it's impossible to have an element as a product or on the right side of the arrow if things are joining together. In most cases, there's only going to be one product, so there's only one thing on the right side of the arrow in both of these reactions. That's going to be common with synthesis reactions. And then lastly, fitting right in with kind of our definition of synthesis is that substances have to combine together or join together, because that's what is going to happen in a synthesis reaction. Your second type of reaction is a decomposition reaction. Again, similar to synthesis. As long as you know what the word decompose means, you're going to be in pretty good shape for figuring out what it is. Decompose means to break down. So in a decomposition reaction, a single compound is going to break down into two or more products. So for examples, if we take the NaCl reaction that we had last time and just reverse it, so instead of having NaCl form, we have NaCl break apart. That would be a decomposition reaction. So this is the complete opposite of one of the reactions we looked at on the other slide. Another example would be the decomposition of ammonia or NH3, which is going to break apart to H2 and N2. You don't need to memorize these reactions, but you do need to recognize that they are decomposition. And we know that they're decomposition because things are breaking apart. So similar to synthesis, there's some key things to look for. Your reactant has to be a compound, because if something's going to break apart, it can't be an element. Elements can't be broken down chemically. So your reactant always has to be a compound. Usually there's only going to be one reactant. That's going to be 99% of the time we see it in both of these reactions. And then lastly, something's got to break down, because that's what happens in a decomposition reaction. Third reaction type is a synthesis reaction, or a single replacement reaction is their third type. Synthesis was the first one. In a single replacement reaction, atoms in one element replaces the atoms in a second element that is in a compound. So that would look something like this. You have 2 KBr plus Cl2 goes to form 2 KCl plus Br2. So what happened is bromine was joined together with potassium. Chlorine was by itself. What happened was chlorine came in and took bromine's spot. So they switched places. At the end, chlorine ends up with potassium and bromine is by itself. And that's always what you're going to see in a single replacement reaction. Another example would be Na2O plus Li goes to form Li2O and Na. Again, what happened? Lithium went in and switched spots or replaced sodium. So one thing is switching spots with another thing, which is why it's called a single replacement reaction. Even more importantly than synthesis and decomposition, for these you need to know what to look for. Synthesis and decomposition you can kind of figure out based off of just knowing what those words mean. It's less likely with single and double replacement. So for single replacement, you're always going to have an uncombined element. Cl2 is an uncombined element because it's not bonded with anything other than Cl. Lithium is an uncombined element. You're always going to have an element on its own in a single replacement reaction. And the other thing is going to be a compound. So both of these things are compounds. So on your reactant side, you're always going to have an element and a compound. An element and a compound. That's always going to be the case. And then the last thing to look for in synthesis is that the element by itself is going to switch spots and go into the compound. So lithium went in, took sodium's spot, leaving sodium now by itself. Our last reaction type then is going to be a double replacement reaction. A double replacement reaction is exactly what it sounds like. Two things are going to get replaced. So in a double replacement reaction, two compounds are going to switch the element that they're bonded to. So if we look at an example, it would be something like this. NaCl plus LiF goes to form NaF and LiCl. So this time, instead of having an element in a compound, we have two compounds. And what happens is both things switch what they're bonded with. In this case, chlorine and fluorine switch spots. You could also say that sodium and lithium switch spots. We're really saying the same thing, but we end up with two different compounds based on these switching. You could do the same thing in a second example, where you have sodium or silver nitrate, AgNO3, and CaCl2, and you end up with AgCl and CaNO3, 2. Again, you don't need to memorize these equations or anything. You just need to know what to look for. Biggest thing, in double replacement, you're always going to have two compounds. Single replacement, you have an element and a compound. Double replacement, you have two compounds. It's the easiest way to identify which one is which. And then both compounds are always going to switch what they're bonded with. Last thing to do real quick is just take a look at a couple real quick examples to kind of identify your reaction type. So if we look at this first one here, we have H2 plus O2 goes to form H2O. You have two things joining together, which means it's going to be a synthesis reaction. For number two, you have things switching spots. So it's either going to be your single replacement or double replacement. It's not synthesis. It's not stuff joining together. It's not something breaking apart. So you need to figure out if it's synthesis or single replacement or double replacement. That comes down to, is it an element and a compound or two compounds? Zinc is an element and H2SO4 is a compound. So if we have an element and a compound, that tells us that we have a single replacement reaction.